given a page reference string and you have to find the number of page faults in this particular question. Here the number of frames is 4. So paging is a memory management technique and the concept of paging is used to remove external fragmentation. So here the main memory is divided into frames and the process is divided into pages. And there is a page table which keeps track of the pages where they are present in the main memory. So any page can be present in any of the frames, and the main reason it removes external fragmentation because the frames are not required to be in contiguous manner, and the page size is equal to the frame size. So these are the few important things which we need to remember. And so the logical or the virtual address which is generated by the CPU is stored in a set of blocks which are known as pages, and the physical address which is generated by the memory is stored in frames. So, and what do you mean by page fault? Page fault is when the page is not resident in your memory. So we have the number of frames, like here in this particular question the number of frames is 4 and the page string which is given is 20. So as we can clearly see that the number of frames is much smaller than the number of pages. So we need to place the pages which are required at that particular instant in the frame, and then we need to remove the pages and insert those pages in the frame which are required at that particular instant. For that we need page replacement algorithm. So like here we have 4 frames. So initially the 4 pages 1, 2, 3 and 4 can be inserted without any problem. But when the next page is required, we'll have to check whether that particular page is already existing in the memory. If the page already exists in the memory, then we can say that there is a page hit. So there are two terms which are very important. One is your hit. What is a hit? If the page which is required is already present in the memory, then we say that it is a page hit. And next is your fault or page fault. So what is page fault? If the page which is required is not present in the memory, then we say that we have a page fault. So these two words are very important. One is your page hit. If the page which is required is present in the frame or is present in the memory, then we say that we have got a page hit. Or otherwise, if the page is not present in the memory, then it is called a page fault or a miss. So we have to find the number of page faults. So initially all the frames are empty. Let's suppose like here I am drawing the frames. So maybe 0, 1, 2, 3. So initially always it is the case like none of the pages is present in your memory. So initially all the frames are empty. So what we need to do, we need to see the string and check what page is required, and then we call that page and we insert it in memory. So initially I require page 1. So 1 is inserted in memory. So that was not already present and we had to call that particular page. So here there is a miss. So there is a page miss is there because the page which was required is not present in memory. So if the page is not present in memory, then we get a page miss. And if the page which is required is already present, then we get a hit. Clear? Now, there are various techniques for replacement. Let's first see how the pages are inserted. So initially I have 4 frames. I required page number 1. I inserted page 1. Next, let me write the string. Actually, leave it. Or let me write the string over here only to avoid confusion. 1, 2, 3, 4, 2, 1, 5, 6, 2, 1, 2, 3, 7, 6, 3, 2, 1, 2, 3 and 6. So this is my string. Now initially 1 was not present. I need to call that particular page. So there is a page miss. the next instance, what will happen? 1 is already there in memory. I need 2. So 2 is not present in memory. So I need to call 2. So I'll insert 2. So again, what I got a page miss. Next, I need 3. 1, 2, 3 was not present in memory, and one frame is all still empty because only 3 pages have been called and I have 4 frames. Next, one, 2, 3, and one frame was empty, so I inserted 4. So till here there is no problem and no confusion in any of the page replacement algorithm. The first, like the number of pages, if I have 4 pages and 4 frames, then up to 4 pages there won't be any confusion. Like if I have 3 frames, then up to 3 pages to be inserted, where like when till I have to insert 3 pages, there won't be any confusion. Now the confusion comes. Now let's suppose if I have to insert a new page, maybe 5 over here. So obviously 5 is not present in memory. So what will I have to do? I'll have to replace one of the pages and I'll have to create a space for this page, new page, which is 5. So I'll have to do that. But in this particular case, what page I require next? It's 2. So I'll check whether 2 is already present in memory or not. So I can see that 2 is already present in memory. So nothing has to be done. The configuration remains as it was and I got a hit. Next, after 2, next page which I require is 1. So I'll check whether 1 is present in memory or not. As I can see, 1 is also present already in memory. So again, we got a hit and there is no confusion. So now the confusion arises. So what happens now? Now I require 5 and 5 is not present in memory. So here the concept of page replacement comes. So here I need 5 to be present in memory, but 5 is not present in memory and I require page 5. So what I need to do, I'll have to remove any of the pages from the memory and insert 5. So here the page replacement algorithm comes into play. So there are different page replacement algorithms which we are going to learn. So the very first one is your FIFO. So what is your FIFO? We know FIFO is first in, first out. So the page which is assigned the memory first will be replaced first. Simple. So what happens in FIFO? Page which is assigned the frame first will be replaced first. Simple. So what is happening in FIFO? The page which is assigned the memory first will be replaced first. So here, as we can see, 1 has been there for the longest duration. Let's count the number of 1. 1 is there for 1, 2, 3, 4, 5, 6 times. 2 is for only 1, 2, 3, 4, 5 times. 3 is for 1, 2, 3, 4 times, and 4 is for 3 times. So obviously 1 has been in the memory for the longest duration. So oldest page over here is 1. So what we are going to do, we are just going to remove 1 from the memory, and in place of 1, what we are going to do, we are going to insert 5. So here again we got a miss. Page miss happened. So next what we have to do, we need 6. So I'm going to check whether 6 is already present in memory. As I can see, the pages which are present in memory right now is 5, 2, 3 and 4. So 6 is not present in memory. So obviously I'll have to remove the page, any of the pages, and insert 6 in that particular frame. So I'll check. So 5 has been there for one instance only, one time. 2 is there for 1, 2, 3, 4, 5 times. 3 is for 1, 2, 3, 4, 5 times. 4 is for 1, 2, 3, 4 times. So the longest duration is for 2. So 2 has been inserted first among the 4 pages which are there. 5, 2, among 5, 2, 3 and 4, which has been for the longest time? 2. So which page we are going to remove? We are going to remove 2. So we are going to remove 2 and we are going to insert 6 over here. So now the configuration becomes 5, 6, 3 and 4. Next, what's going to happen? I need 2 again. I just removed 2 and now I need 2 again. So what I have to do? I'll have to, so there is a miss again. Now what I need 2 again. So what I'll have to do, I'll have to remove any of the pages and I'll have to insert 2 in its place. So now 5 has been there for 2 times, 6 for 1, 3 for 1, 2, 3, 4, 5, 6 times, 4 for 5 times. So the oldest page over here is 3. So what we are going to do? We are going to remove 3 and we are going to insert 2 in its place. Done. So again we received a page miss. We got a page miss. Next I'm going to check. Now I need 1. 1 is not there in memory. So the oldest page over here is 4. So what we are going to do? We are going to remove 4 and insert 1 in its place. So again we got a page miss. Next in sequence is 2 again. So I'll check whether 2 is present in memory. 5, 6, 2 and 1. So 2 is present in memory. So obviously I got a page hit. So 5, 6, 2, 1. I got a hit. So I'll write H over here. Next what I need? I need 3. So is 3 present in memory? So I'll check 5, 6, 2 and 1. No, 3 is not present in memory. So what I need to do? I need to replace a page and insert 3 in its place. So as we are using FIFO, first in, first out. So the page which came first will be removed first. So we'll check. Like here I have 5. 5 has been here for 1, 2, 3, 4, 5 times. 6 has been here for 1, 2, 3, 4 times. Then I'll check for 2, 1, 2, 3 times and 1, 2 times. So which page will be removed? 5. 5 has been here for longest time. So what I'll do? I'll remove 5 and in place of 5 what I'm going to write? 3. So 3, 6, 2 and 1. So here again I got a page miss. Next I need 7. So is 7 present in memory? 3, 6, 2 and 1 are present. As I can see, 7 is not present in memory. So what we are going to do? We are going to replace the oldest page. So we'll have to check again. 3 is the newest page and 6 has been here for 1, 2, 3, 4, 5 times, 2 for 1, 2, 3, 4 times, 1 for 1, 2, 3 times. So which is the oldest page? 6, because 6 has been here for the longest time. So what we are going to do? I am going to remove 6. So 3, 7, 2, 1. And here again what I got? I got a page miss. Next what I'll see? I need 6 again. I just removed 6 and I am getting 6 again. So as we can see, this is not one of the best policies to be used, but this is it right now. So I need 6 again. So I'll have to replace one of the pages from the frames and insert 6. So for that we are following which policy? FIFO. So we'll remove the oldest page. So let's check which is the oldest page. 3 has been here for 2 times, 7 for 1, 2 for 1, 2, 3, 4, 5 times, 1 for 1, 2, 3, 4 times. So the oldest page over here is 2. So 3, 7 will remain intact and in place of 2 we are going to insert 6 and 1 will remain intact. Next we have 3. After 6 we have 3. So 3 is already present in memory, so no problem. So there is a miss and next we have 3, 7, 6 and 1. So 3 was already present, so we have a hit. Next page required is 2. So 2 Is 2 present in memory? 3, 7, 6 and 1 are present in memory. 2 is not present in memory. So what I need to do, I need to replace the oldest page. So I'll have to check for that. 3 has been here for 1, 2, 3, 4 times. 7 for 1, 2, 3, 6 for 1, 2 and 1 for 1, 2, 3, 4, 5, 6. So the oldest page over here is 1. So in place of 1, what I'll do, I'll insert 2. So the page 1 will be replaced and in place of 1, 2 will be inserted. Next, I require 1. So what I'm going to do, I'm going to check for the oldest page, and the oldest page over here is 3 has been here for 1, 2, 3, 4, 5 times, 7, 1, 2, 3, 4 times, 6, 1, 2, 3 times and 2, 1 time. So oldest is your 3. So in place of 3, what I'm going to insert 1. So 1, 7, 6, 2. Next, what I see, so here you have a miss, you have a miss. Next, I need 2. So I'll check 1, 7, 6 and 2 are present here in your memory. So obviously 2 is here in your memory. So there is a 1, 7, 6 and 2. You got a hit. Next, you require 3. So for 3, I'll have to check for the oldest page. So the oldest page over here is 1, 2 times, 7, 1, 2, 3, 4, 5, 6 times, 6, 1, 2, 3, 4, 5 times, 2, 1, 2, 3 times. So the oldest page over here is your 7. So I'll replace 7 with 3, 1, 3, 6 and 2. So again there is a miss. At last you require 6, which is already present in memory. So you have 1, 3, 6 and 2. So this is your FIFO algorithm and this was your hit. So this is your FIFO algorithm where you have 4 frames and the string which given to you was of size 20, right? 20 pages were to be called. So I had to compare the number of page faults. So let's check how many hits you got. 1, 2, 3, 4. 2 hits over here. 1, 2, 3, 4, 5 and 6. So the number of hits I got over here is 6 and the total number of pages is your 20. So page fault will be, page fault is, you can count as well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14, or you can subtract the number of pages and the number of page hits. 20 minus 6, 14. So anyway, you will get 14 as your answer. The first page replacement algorithm which we learned is FIFO, where the page which is assigned the frame first was replaced first. Now the second page replacement algorithm is your LRU, that is your least recently used. So here we are going to look at the past and see which page was not used in the recent past. So here what happens, the page which has not been used for the longest time. So the page which has not been used for the longest time is chosen for replacement. So what happens over here? So the page which has not been used in the past for the longest time is chosen for replacement. So let me write the string again over here. So the string is 1, 2, 3, 4, 2, 1, 5, 6, 2, 1, 2, 3, 7, 6, 3, 2, 1, 2, 3 and 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. And the number of page frames I have is 0, 1, 2, 3. So I have 4 page frames over here. So as we saw earlier, initially all the frames are empty and I have to insert the first page. So no difference from the past. I'll insert 1 and I got a miss. Next I need to insert 2. 1 is already here, so I'll insert 2. 2 frames are still empty, but this is a page miss because 2 is not already present in memory. Next I have 3. So what I'll do, I'll insert 1, 2, 3 I'll insert, and there will be an empty frame over here, but you get a page miss because 3 is not already resident in memory. 3 is not already present in memory. Next I have 4. So what I'll do, I'll insert 4 in memory, 1, 2, 3 and 4, and again there is a page miss. So as I told earlier, there is no difference for the first 4 pages. There is no difference between your LRU and your FIFO. But now I need page 2. So I'll check whether 2 is already present in memory. So 2 is already present in memory. So there is no difference in configuration. So there is a page hit and 2 was already present in memory. So no difference from the past here as well. So again I need 1. 1 is already present in memory. So you got a hit again, and this is the configuration for FIFO and LRU, both the page replacement algorithm. This is the case. So we did not need any replacement till now, so none of the pages have been removed as of now. Next what happens? I need 5. So I need to check which page has not been used recently in the past. So I'll see I'll backtrack my string. So here 1 is the most recently used. So before 5, 1 is your most recently used, and next I used 2. So the most recently used page over here is your 1. So in FIFO, 1 would have been chosen because 1 is there, have been here for the longest duration, because 1 was inserted first. But during the execution, I needed 1 again. So here we'll forget about all the things in the past and we'll just remember that 1 has been called over here in the first position because the most recently used page is your 1. So we'll keep a track that 1 is the most recently used. Next I'll backtrack like 2. Now 2 is your used over here. So first 1 has the highest priority. So this is the most recently used. Second I'll check for 2. 2 is the second most recently used. Then you have 4. So 4 is your third most recently used. So next you have 3. So 3 was your least recently used. So what you have to see over here, like whenever a page is called, like 5 is called and that is not present in memory, you'll have to see backwards. So for how many frames I'll have to see? Like there are 4 frames, so I'll see for the 4th frame. 4 frames. So like 1 is here. So 1 is the most recently used. Then 2 is the second most recently used. 4 is the third most recently used, and 3 is the least recently used. So which page will be chosen for replacement? 3. So what we are going to do? We are going to replace 3 with 5. Why? Because 3 was the least recently used. So let's check once more time. You need 5. So 5 is not present in memory. 5 is not present in memory. So we'll need to backtrack. We need to see which pages are called in the recent past. So recently you needed 1. So 1 is the most recently used page. Then you needed 2. So 2 is the second most recently used page. Then you needed 4. So 4 is your third most recently used. And at last you have at the 4th frame You have 3. So 3 was the least recently used page. Next 6. You require 6, so you will have to check whether 6 is present in memory. No, you have 4 pages, 1, 2, 5 and 4. So 6 is not present in memory. So again, what you need to replace a page which is present in memory with 6. So let's draw it. Now for inserting 6, what you have to do, you have to see backwards again. So which is the most recently used page now? 5. So 5 is the most recently used. So we are not going to replace 5. Then you have 1. So 1 is the second most recently used. So you are not going to replace 1. Then you have 2. So 2 is the third most recently used page. So you are not going to replace 2. So which is the least recently used page? 4. So what you are going to do? You are going to remove 4 with 6. So there you had a page miss, and this is your configuration. So next you need 2. So we can see 2 is already present in memory. So there is no confusion. You will just copy it as it is and you got a page hit. Then you need 1. 1 is also present in memory. So 1, 2, 5 and 6. You got a page hit. Next you require 2 again. So you will do 1, 2, 5 and 6 and again you got a page hit. Next you require 3. So is 3 present in memory? No, 3 is not present in memory. So what we are going to do? We are going to replace a page which has been here, which has not been used for the longest time in past. So we'll see what I need to insert. 3. So I'll look in the past. So 2. So 2 is the most recently used page. So obviously we are not going to replace 2. Second most recently used is your 1. So we are not going to replace 1. Next we have 2 again. So obviously I am not going to replace 2. 2 is the used page. Next we have 6. So 6 is the third most recently used. So 6 will also not be replaced. So what will be replaced? Now least recently used page is your 5. So which page you are going to replace? You are going to replace 5 with 3. So you got a page miss and you replaced 3 with 5. So now the configuration is 1, 2, 3 and 6. Next, which page you require? You require 7. So for 7, what you are going to do? You are going to replace the 7 is not present. So you are going to replace the least recently used. So you're going to see backwards again. So 3 is the most recently used page. So I'm not going to replace 3. Then you have 2 is the second most recently used. I'm not going to replace 2. 1 is the third most recently used. I'm not going to replace 1. 2 is already there, no confusion. Then you have 6. So which page you are going to remove? You are going to remove 6. So what will be your current instance? What will happen? You are going to insert 7 in place of 6. So the configuration is your 1, 2, 3 and 7. So there was a miss and you replaced 6 with 7. Next, what I need 6. So is 6 present in memory? No, we just replaced that. So what I am going to do? I am going to replace a particular page. So I'm going to track backwards. Before 6, the most recently used page is your 7. So 7 will not be replaced. Next second most recently used is your 3. So 3 will not be replaced. Third is your 2. So 2 will not be replaced. So which is the least recently used? 1. So 1 will be replaced. Next you have, so there was a miss again. Next you have 3. So 3 is already present in memory. Very nice. So we'll just write a hit over here. Next you need 2. So 2 is also present in memory. So no confusion. You are going to have a hit over here. Next you require 1. So 1 is not present in memory. So what we are going to do? We are going to replace the least recently used. So we'll see backwards again. the most recently used page is your 2, so 2 will not be replaced. Second most recently used page is your 3, so 3 will also not be replaced. Third most recently used page is your 6, so 6 will also not be replaced. So the least recently used page is your 7, so 7 will be replaced for 1. So you got a miss over here, and the configuration is 6, 2, 3 and 1. Next, I need 2. 2 is already there in memory, so no confusion. 6, 2, 3 and 1, so you got a hit. Next, 3 is already there in memory, so 6, 2, 3 and 1, you got a hit again. Next, you need 6 is already there in memory, 6, 2, 3 and 1, so you got a hit again. So this was your least recently used configuration. Now you need to calculate the number of page hits. So how many hits you got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you got the number of hits to be 10, and the total number of pages was 20. So the number of page faults which you got is 10. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, or you can even get it by number of pages is 20. So page faults is 20 minus number of page hits 10, which is 10. So the number of page faults which you got by LRU is your 10, and the number of page faults which you got by FIFO is 14. So next we have to see for the optimal page replacement. So this is your page replacement string, the page reference string, and now the next page replacement algorithm which we are going to use is your optimal page replacement algorithm. So what does optimal page replacement algorithm does? So here, like in LRU, what I was doing, what is done actually is we look at the past, that which page has not been used in the past might not be used in the future as well, but we don't know the future as of in least recently used LRU. But in optimal page replacement algorithm, we can see through the future, and we can see which page will not be used in the future will be replaced first. So here what we do, we replace the page that will not be used in the future. Like if I am at a particular instance, then I can see in the future that which particular page will not be used, and then I'm going to replace that particular page. So what is done here, you replace the page that will not be used for the longest duration. So here what you are going to do, you are going to replace that page which will not be used in the longest duration. In LRU, I was watching the past. I went to the past to see which page is not being used recently. Here I am going to see the future and check which page is not going to be used in the future. So here again, let me write the string. Like you have 1, 2, 3, 4, 2, 1, 5, 6, 2, 1, 2, 3, 7, 6, 3, 2, 1, 2, 3 and 6, and the number of frames I have is 4. So let's draw the frames once more. 0, 1, 2 and 3. So initially the frames are empty, so what you need to do, you just need to insert 1. So obviously there is a page miss. Then you need 2. So what you will do, you will insert 2. So there is a page miss again. Then you have 3. So what you are going to do, you are going to insert 3, miss again, then 4, 1, 2, 3 and 4, miss again. Then you have 2 which is already present. So 1, 2, 3 and 4. So you got a page hit. Then you have 1 which is already present. So 1, 2, 3 and 4. You got a page hit. Then you have a problem. Like you have 4 pages. So up to here, for this particular string, up to here there is no difference in any of the page replacement algorithm. But when a new page comes which is not present in memory, all the confusion, all the problem arises. Now here I need to insert 5, and as I can see it's not present. So what I'm going to do, I'm going to replace a page from, I'm going to see after 5, and I'm going to see which page will not be used and is present in memory, and that particular page will be replaced. So let's check. Like I need to insert 5, so I'll not see 5. 6. Is 6 present in memory? So it's not present, so there is no chance of removing that, replacing that rather. So nothing to do with 6. So 2. So 2 is to be used in future, so I'm not going to replace 2. Then I have 1. 1 is used in future, so I'm not going to replace 1. Then I have 2 again. 2 is already here. 3. So 3 will be used in future, so I'm not going to replace 3 as well. And then you have 7, you have 6, you have 3, 2, 1, 2, 3, 6. So 4 is not at all being used anywhere in the future. So obviously the best page which has to be removed over here is 4. So let's check one more time. Like I need a frame, an empty frame, to insert 5. So what I need to do, I need to look into the future. I'll look into the future, like which particular page is not going to be used in the future for the longest duration, and then I'm going to remove that particular page. So here I am at page 5. So I'm looking into my future, like 6. 6 is not present in memory, so I cannot remove that particular page. So next 2. So 2 is present in memory, so it is being used. The very next page after 5 is 6, and then I need 2, so I'm not going to remove 2. Then I need 1, so I'm not going to remove 1. Then I need 2 again, so 2 obviously will not be removed. Then 3 is required, 3 will not be removed. Then 7 not present in memory, so no confusion. 6 again not present in memory. 3 I present in memory. Then 2, then 1, then 2, then 3, and then 6. So 4 has not been used, and it's not being used, it's not being used at all. Like it is required only once, like only once. Over here I required 4, so why to waste a frame for 4? So obviously this is the principle which is being used over here. So what I'll do, I'll replace 4 with 5. So I got a page miss, and 5 is inserted over here. So next I need 6. So again 6 is not present in memory, so obviously I need to remove a page to create a space for 6. So I look into my future again. So 2 is the most, the very next page required, so 2 will not be removed. Then 1 will not be removed. Then 2 again will not be removed. 3 will not be removed. So which page will be removed? Now 5 will be removed. So we'll remove 5, and in place of 5, what I am going to do, I am going to insert 6. So there is a miss again. Next 2 is required, so 2 is already present in memory, so no confusion. You got a page hit. Then 1 already present in memory, so you got a page hit. Next 1, 2, 3 and 6. 1 already present, so 2 already present, so page hit. Then 3, where am I? I am up to, I did for 2 hit, 1 hit, 2 hit, then 3. So 3 is already present in memory, so 1, 2, 3 and 6, so a hit again. So I got 4 continuous hits. Now next I need to insert 7. Is 7 present in memory? No. So 7 is not present in memory, and I need to insert 7. So what I need to do, I need to look into the future and see which page will not be used for the longest duration, and then I'll replace that particular page. So let's see. After 7, the very next page which is required is 6. So I cannot remove 6. So 6 has to be here. The second page required is 3. So 3 will be here. Then 2. 2 is also needs to be here. So at last I need 1. So 1 is the page which will not be used in the future for the longest duration. So I'll replace 1 with 7. So now your configuration is 7236 and you got a page miss. Now for next 3 pages, like 7 is here, the 6 is already present, so 236 you got a page hit. Next for 3 is already present, so you got a page hit. 7, 2, 3 and 6. Then 2 is already there, 7, 2, 3 and 6, so you got a page hit. And next, now you need 1 which is not present in memory. So what I need to do, I need to replace a page. So I'll look into the future. 2 is required, 3 is required, 6 is required, but 7 is not required. So I'll replace 7 with 1, 2, 3 and 6. And similarly, now I'll get, there is a page miss, and now no misses. 1, 2, 3, 6, there is a hit. Again for 3 there is a hit, 1, 2, 3 and 6. And then for 6 as well you have a hit, 1, 2, 3 and 6. So this is your final configuration. So here the total number of hits you got is, you can count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's count it one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the number of page faults you got is 1, 2, 3, 4, 5, 6, 7, 8. So obviously this is 20 minus 12. This is 8. So optimal page replacement is the best, because I can look into the future and see which particular page is not being used for the longest duration, and then you are going to replace that particular page. So this is the thing. So this is a very important question for your exam. It came in 2012, 2015 for 14 marks, 2016 also for 14 marks, and in 2018 you got this for 7 marks. So there was a theoretical question in 2015 I think, and the same simple question, these 3 algorithms only you had to use, like LRU, FIFO and optimal page replacement for a given string, and that question was for 14 marks. So this is a very important question and you can easily fetch 14 marks from this. So this is it. Thank you.